Okay, good morning. It's January 10, 2023. It's almost 3 o'clock in the morning. Okay, this is Professor David J. De Los Reyes. I will now be on lesson number 2 on my advanced mathematics subject matter. Lesson number 2. Lesson number 2 is the solution of the second order non-homogeneous differential equation. On my lesson number 1, I discussed the concepts on how to compute for the total general solution of the higher non-homogeneous differential equation. The total general solution is actually, it will be the sum of the complementary and the particular solution. Okay, let's proceed. This is lesson number 2 on my subject matter, advanced mathematics. So this is advanced math, lesson number 2, example evaluation number 1. The given non-homogeneous differential equation is a second order non-homogeneous differential equation. This is y double prime. So the order is actually 2. Or maybe the next time around, I will give y triple prime, so it's not second order, it's a third order. Or the next time again, it could be y 4 prime, so it's higher than the second order. But for tonight, or for this morning, the differential equation is actually second order non-homogeneous because the right hand side is not equal to 0. Okay, I will try to read the problem. Find the general solution. We are given the differential equation y double prime minus 4y equal to 3 sine of 2x. Find the general solution. General solution is actually y sub c plus y sub p. Okay? The total general solution is the value y sub c plus y sub p. Y sub c is complementary solution. Y sub p is the particular solution. Okay, let's try to bring out the complementary solution. For the complementary solution, it is the same as the solution under the second order differential equation under the subject matter differential equation. Okay? Advanced math is still a differential equation, but it's higher, okay? That's why it's advanced math. Okay, let's try to bring out the complementary solution. We are now familiar with this because the example evaluation problems and application problems all involves this solution. Okay, let's try to bring out the complementary solution. Complementary, this is E, okay? Y sub c is equal to k e raised to mx. Okay, you are popular with that. If we take the first derivative, we could place it as y prime sub c. Actually, y prime is actually dy dx. Okay, but for us to be for us to be more systematic on the board, okay, we will just put y prime as the first derivative. So y prime is actually dy dx equal to km e to the mx. Okay? Take again the derivative of the first derivative. So it will become y double prime c or y sub c double prime, meaning the second derivative of the complementary solution. Okay? Equal to, same as from the second order differential equation, km square e raised to mx. Okay? Next move, substituting and equate to 0. This is new under advanced mathematics because, no, it's not new because it was the same as the solution under the second order differential equation. Because under the second order differential equation, the right hand side is actually equal to 0. Okay? Okay, I will check my camera. So the next move after the differentiation of y prime and y double prime, substituting and equate to 0, km square, we are following this, minus 4 times y, which is k e raised to mx, and this should be equal to 0. Why did I equate to 0? The right hand side is not 0. Okay, for the complementary solution, at the time we are taking the complementary solution, we will equate the right hand side equal to 0. Okay, that's the correct procedure for the complementary solution under advanced mathematics. Okay, so what will come out? Km square e to the mx, that's the second derivative, minus 4k e raised to mx, and this should be equal to 0. There is a common factor k, and there is another common factor e to the mx. Okay, so what remains will be an m square minus 4 equal to 0. So we now know why we equated this to 0. At the time we are taking the complementary solution, we equate the right hand side equal to 0. Okay, don't argue with me with that one. That's the procedure. Okay, so m square now will be equal to plus 4, that is after the transposition. And now, since this is positive, this should become plus or minus the square root of 4. And luckily, we could take the square root of 4, it's 2, right? So m1 will be positive 2, and m2 is equal to negative 2. So we are given two roots now, plus 2 and minus 2. They are both real and unequal. So if we try to bring out the complementary solution, it will be k1 e raised to m1x plus k2 e raised to m2x. Okay? We've been saturated with this kind of solution under the last topic, under the differential equation, right? So if we now try to substitute the value of m1 and m2, the complementary solution now will be k1 e raised to x plus k2 e raised to minus 2x. The subscript C here refers to complementary solution. Okay? Okay, let's try to bring out the particular solution. This is new because we don't know yet this under the last topic, under differential equation. We have not discussed this one. It's only under advanced mathematics that we will be discussing particular solution. Okay, for the particular solution, it should be a solution by observation. Why by observation? I place it here, y with the subscript p, meaning particular solution, equal to an unknown constant a times sine of 2x. Why did I took a sine of 2x as a particular solution? If you try to observe the right hand side, it is 3 sine of 2x, right? So I think it follows that the solution should be in terms of sine of 2x. But for the meantime, we do not know the value of a. That is our problem now. But we could solve for the value of a by following the procedure I will be presenting. If I assume that the particular solution is a sine of 2x, okay, I will now proceed with the differentiation. First derivative of the particular solution, or yp prime equal to, take the derivative of this, it should be a, okay, it should be a. The derivative of sine is actually cosine of 2x, right? Times the derivative of the angle. The angle is 2x. So the derivative of that will be 2 times 1. Okay? So 2 times a is actually 2a cosine of 2x. So I put it here, yp prime is actually 2a cosine of 2x. That's it. Right? Take again the derivative of the first derivative. So what will come out will be yp double prime. Take again the derivative of this. What will come out? It should be equal to 2a. The derivative of cosine is minus sine of 2x. Okay? Times the derivative of its angle. The angle is 2x. So the derivative of that will be 2 times 1. What will come out? 2 times 2 will be 4. This is negative sign, so this is negative. So yp double prime will be negative 4a sine of 2x. This is. Okay? So we are now given yp. We are now given yp double prime. So if we try to take the value of this one and the value of this one, we put it in the original problem, what will come out? Y prime, for the meantime, y prime refers to yp, right? So I will copy minus 4a sine of 2x. It is this. Okay? Minus 4 times y. Minus 4 times y. But what is y? For the meantime, we are referring to yp, right? So 4 times a sine of 2x will be minus 4a sine of 2x equal to the right hand side. For the particular solution, we will take the right hand side. Okay? We don't equate it to 0. We will take the value as it is given, right? So this will become 3 sine of 2x. Okay? So what comes out now will be this equation here. It is the same under integral calculus, in which we are solving for the unknown coefficients. So the proper procedure is, it should be equating coefficient of like terms to compute for the unknown constants, right? The only terms on the given equation are sine of 2x, right? So it's a must that all terms with sine of 2x equate the coefficient. For the first one, for this one here, first one here, negative 4a, the coefficient is negative 4a. Second one, sine of 2x again, right? The coefficient is again negative 4a. And this should be equal to, the right hand side, we got the sine of 2x, right? And what is the coefficient of that one? It is 3. Okay? That's why equating coefficient of like terms, right? Minus 4a will be negative 8, a equal to 3, therefore a will be negative 3h. The unknown coefficient of the particular solution is actually negative 3h. So we could now bring out the particular solution by following this one. Since we assume that the particular solution is actually a sine of 2x, and we now know the value of a, therefore the particular solution now will be negative 3h sine of 2x. So this is the complementary solution. This is the particular solution. So to compute for the general solution of the given second order differential equation, the total general solution now will be the complementary solution plus the particular. Complementary is this one. So k1 a to the 2x, k2 a minus 2x, plus the computed particular, minus 3h sine of 2x, okay? And that's our final answer. Meaning, the solution of this second order differential equation, and it is non-homogeneous, is actually this equation here. Y equal to k1 a to the 2x plus k2 a to minus 2x minus 3h sine of 2x. That's our final answer. Okay, let's check the validity of our answer. We must have to check it. I must have to prove to you guys that our solution is correct. This is y, right? Take the first derivative of this one. Y prime will be the differential of the first one. It should be k1 e to the 2x times 2 times 1. So that will be 2k1 e to the 2x. The second part will be k2 times e to the minus 2x. But the derivative of the exponent is actually negative 2. So negative 2 times k2, it will become negative 2k2 e to the minus 2x. For the sine function, okay, it will be constant times my sine function, right? So what will come out? It should be negative 3h. The derivative of sine is actually cosine of 2x. times the derivative of the angle, which is actually 2 times 1. So what will come out? 3 times 2 will be 6. This is over 8. It should be negative, right? So it will be negative 6/8 cosine of 2x. That's the first derivative of our final answer. Take again the derivative of the first derivative. So what will come out will be y double prime will be equal to, it's the same. 2k1 is a pure constant, okay, times the derivative of 2x, which is 2. So 2 times 2k1, it will become 4k1 e to the 2x. For the second part, minus 2k2 times minus 2, minus that it will become plus 4k2 e to the minus 2x, okay? Because the derivative of the exponent is negative 2. Negative, it will now become plus after taking the second derivative. For the cosine function, this one, it will be negative 6/8. The derivative of cosine is actually negative sine times the derivative of the angle. The derivative of the angle is actually 2 times 1. So 6 times 2 is actually 12, right? This negative is negative, so it is now plus. This is over 8 sine of 2x. Okay, sine of 2x. That's the second derivative. Then we will try to multiply the final general solution by negative 4. Multiply all these terms by negative 4. Distribute this one. So what will come out? Y times negative 4 will be negative 4y. Okay? Negative 4 times k1 e to the 2x, it will become negative 4k1 e to the 2x. Negative 4 times k2 e to the minus 2x will be negative 4 k2 e to the minus 2x. And negative 4 times minus 3/8, this is minus, this minus, so it's now plus, right? Okay, 4 times 3 is 12. This is over 8 sine of 2x. Okay, then try to add y double prime. Try to add. The operation is addition, okay? Okay. Y double prime plus minus 4y, it will become y double prime minus 4y equal to, if we try to add this equation here in the next equation, this one here cancel with this, right? And this one here cancel with this, okay? The last part, it will not cancel because this is sine of 2x, is sine of 2x, right? This is plus, this plus, the operation is plus, so this is plus. Plus 3, okay? And we are now adding fractions. The coefficient of the first sine 2x is actually 12 over 8. Okay? Plus 12 over 8. Okay? We are adding two fractions under the same denominator. Okay? So just add the numerator all over that same denominator. So 24 over 8 is actually 3. So what comes out? After taking the sum of y double prime and the product of the value of negative 4y times all of this, what comes out is y double prime minus 4y equal to 3 sine of 2x. And what is this? It is the original second order differential equation. It is this. Okay? So after taking the second derivative and the value negative 4y, then take the sum, what comes out is the given original differential equation. It's checked. So our solution is correct. This solution here is correct. Okay, that's it, guys. That is how we work under advanced mathematics. It should always be a particular complementary solution plus a particular solution. For the complementary, it is the same as the last topic under differential equation, okay? The only thing is that we will equate the right-hand side equal to 0 to solve for the roots. For the particular solution, use your eyes. Try to visualize the given right-hand side. The given right-hand side is actually in terms of sine functions. So assume that the answer for the particular should be also a sine function. That's why I place it here. Y particular is an unknown constant A sine of 2x. I just follow this one, right? Because supposed to be the answer should be in terms of sine of 2x. But for the meantime, we do not know the value of A, but we could compute for the value of A by using the so-called equating coefficient of like terms. Oh, that's it, guys. That's advanced mathematics. It should always be the sum of the complementary and particular solution. Okay, if you like my long video lesson number 2, please click like. And if you want to subscribe to my channel is at youtube.com/@ProfDavidJ.Reyes. And if you want to share it, please click share. For those who are taking up advanced mathematics, this is for you guys. You will learn something from it. Good morning, Los Angeles.